Hello friends. So we have a expression which is a binomial expression raised to the power n, where n belongs to a positive real number, and we have to identify the values of n for which the expression has a non-zero constant term. By constant we say is the x to the power must be 0 so that the term is not dependent on x. So before moving forward, let us try to understand what is a binomial theorem. So we know the expansion of a plus b raised to the power n is nothing but e raised to the power n plus nc1 a raised to the power n minus 1 b raised to the power 1 plus nc2 a raised to the power n minus 2 b raised to the power 2 and so on, and up to what term? Up to b raised to the power n. So what is the general term for this? Plus 1 term is NCR e raised to the power n minus r into b raised to the power r. What do we mean by general term? Suppose you put r equals to 0, the first term would be NC0 e raised to the power n minus 0 b raised to the power 0, which is nothing but a raised to the power n. NC0 is 1. Now if we have to identify second term, for T2 we have to put r equals to 1, so we get NC1 a raised to the power n minus 1 b raised to the power 1. So this is same as our second term. So if we have to get different terms, we only need to put different values of r to get the different terms. So in our given expression, we have given x cubed minus y by 2x raised to the power n. So using this formula, we will write the general term for this expression. The general term for this expression, which would be TR, will be NCR into A. Here A is 8 cubed raised to the power n minus r into B. Since we have positive sign in between, so we take the minus inside this. 1 minus 1 by 2x raised to the power r. So in this expression, what we do is we will equate the power of x equals to 0. So the power of x would be 3 into n minus r, 3 into n minus r, and here from here we will get the power of x is minus r. So we will be equating it to 0. So when we equate it to 0, we get 3n minus 3r minus r equals to 0, or 3n equals to 4r. So from here we get n equals to 4r by 3. Now we know r varies from 0, 1, 2, 3 up to n. So let us try to see what are the type of values which we can get from here. So if we put r equals to 0, we get n equals to 0 and r equals to 0, which is not an acceptable solution, because in that case the entire term will become a constant. Next is, if we put r equals to 1, we get equals to 4 by 3. Again, in this case also the terms like NCR will not be definable because n is not an integer. So if we try with r equals to 2, we get 8 by 3, again not an integer. Then r equals to 3, we get n equals to 4. So one of this solution is possible. Let us try with r equals to 4, we get equals to 16 by 3. Then r equals to 5, we get n equals to 20 by 3, which is again not an acceptable solution. R equals to 6, we get n equals to 8. So from here we can see only for the multiples of 3, in case of r, we are getting the values of n. So next solution will come r equals to 9, and that would be n equals to 12. And so we can recognize a pattern where r will be moving in the multiples of 3 and n would be moving in the multiples of 4. So we can accept the values of 4, 8, 12 and so on. Or we can write it as 4 times k where k belongs to some positive integer. So this is our solution for k. For more such questions, do visit our website iitacademy.com and register for detailed solution.